Given that x cubed plus y squared plus x tan 2y equals 8, find dy dx in terms of x and y. Given that x equals 3t plus t squared and y equals 1 plus 4t over 3 plus 2t, find dy dt and dy dx, simplifying your answer as much as possible. So let's have a look at this then. We need to differentiate this term by term. It's an implicit function, so run along the row differentiating it all term by term. So part A, here then, differentiating. This is a power, simple. 3 comes down, x to the 1 less, which is 2, plus function of a function. 2 comes down, 2y to the 1, multiplied by the something differentiated. And then we've got a product here, u dv dx. Tan differentiates to, tan goes to sec squared, doesn't it, of the something, multiplied by the something differentiated, because this is a function of a function. The something differentiated is 2 dy dx. So that's u dv plus v tan 2y times du, which is 1. So 1 lot I'll put there in front, equals, and then differentiate, constant goes to 0. So let's tidy it up then and see what we get. So what do we get? We get dy dx then, here and here. So this implies that I'm going to do it in one fell swoop, I think. Dy dx times 2y there. So that's that term done. And then here we've got 2x sec squared 2y. Sec squared 2y. Those are the two lots of things we needed to put in a bracket. The 2y and the 2x sec squared 2y. Because there's a 2 there, isn't there? That can come to the front. And then move this over the other side along with this. So it's equal to minus 3x squared minus this term as well, because you're moving that over, tan 2y. So that tells us then what dy dx equals. It will be this stuff here. If I can just try and write it a bit better. Minus 3x squared minus tan 2y. There it is there. Divided by, I move this from times now down to divide. 2y plus 2x sec squared 2y. Put a bracket around it. And we can tidy this up, and I think it might be worth doing, since we've done a lot of work already. Take a minus out of the top, and it will be 3x squared plus tan 2y. And there's a 2 common underneath, so we can take that out also, can't we, outside a bracket. And then we can put inside the bracket y plus the x squared sec squared 2y. There we go. That's dy dx then for part A. Now let's turn our attention to part B. So we've got this and y, and we need to find dy dt and dy dx. So x equals 3t plus t squared. And let me just write down y, so that we don't need to keep going back up. 1 plus 4t over 3 plus 2t. 1 plus 4t over 3 plus 2t. 1 plus 4t over 3 plus 2t. So let's get dy dx then. This is part B. The first part was dy dt. So let's turn our attention to this part of the problem now. So it will be v, 3 plus 2t, more than one term, put a bracket, times du dt, which is 4, minus u, more than one term, put a bracket, times dv dt, which is 2, all over v squared, isn't it? Which is this squared. More than one term, put a bracket, it's that whole thing squared. So we've got how many t's? We've got 8t here. Take away 8t, so they'll cancel. And the constants, we've got 12. Take away 2 is 10. So I've done it in one fell swoop over 3 plus 2t squared. So that's dy dt then. Now part 2, dx dt, we need first, don't we? Differentiate this, we get 3 plus 2t. So then, dy dx is equal to dy dt divided by dx dt. So it'll be 10 over the 3 plus 2t squared divided by dx dt, which is this. So that just changes that to a cube, doesn't it? Because you divide by another 3 plus 2t. Okay, that's dy dx then. 10 over 3 plus 2t all cubed. Right, it doesn't look like that simplifies further, so that's dy dx then.